Hello, welcome to our salsa classes. Here the question is 31. Number of geometrical isomers of the complex RHC triple bond C R2 PME3 whole thrice is. It is better to write this complex in a simpler notation, that is Ma3CB2. Now it becomes easier to imagine. Okay, this is like counting of GI in coordination chemistry. Now, whenever you see Ma3, always remember to think of a facial. Okay. So if you are thinking of a facial isomer over here, then obviously the other one will be meridonial. Now for a facial, it means in a octahedron, which is 8 faces, one face will be having 3 atoms will be occupying. So you can make a triangle out of that face. See, this is how I can make a triangle. Now, if you want to make the meridonial, simply take one of the PMA3 and put it trans to another one. All right. So this red sphere trans to another red sphere will give you a meridonial. Now here we have two PME3 opposite to each other. So these are meridonial. And we have the alkyne type of ligands trans to each other. Okay. Now to generate the other, had this been A3B3, then only two, FAC and MER. But for this case, when it is A3CB2, 2B can be cis to each other, or AC can be, one of the C's can be cis to one B. Okay. So B can be cis or B can be trans. So here the B are say trans. So B can be cis. So this B and that B are cis. So what will happen? There will be a transmer and there will be a cismer. So all total there will be 3 isomers for this particular compound. Okay. Next. All right. Another question that has been directly asked from Atkins. Okay, you can also consult for a better explanation. I think Mesler-Tar, okay, also has a beautiful explanation over this particular thing. Here, I2 is a violet in solid as well as in gaseous state. However, in acetone or alcohol, it turns brown. Choose the correct statements for the color change. Dissociation of I2 in atomic state, interaction of low-lying sigma orbital of iodine with the lone pair of O solvent, formation of a charge transfer complex. All right. I've already mentioned that B and C are the answers. Why it is so, I'm going to explain. Now, iodine is violet in solid and gaseous and in non-donor solvents like dichloromethane or carbon tetrachloride. Okay. In water, it does not dissolve in water, but it is rather iodine. When combination with Ki, it dissolves in water. So, or in say propanol or ethanol, such Lewis bases, iodine becomes brown. Okay. Now, the color changes from this occurs because solvent solute complex is formed over here. Okay, from the lone pair of the donor molecule O and the low-lying sigma orbital of the dihalogen. Say in this case, it is our iodine. Let's have a look at the MO picture. Okay, how this is happening. Now, this is a crystal structure that was being isolated, okay, and studied. Here, there is obviously, we are having a bromine, but you can think also this is like an iodine, okay, not an issue. Now, here, this is acetone. So, we have the lone pairs of the acetone combining with the sigma star of, say, bromine here. You can consider iodine. All right. So, this is the MO picture. sp2 hybridized lone pairs are combining with the sigma star of the bromine. That means we can generate a MO. We can generate a MO something like this. As you can see, this is the sigma star for the iodine or bromine. This is sp2 plus sp2 minus sp2. So there are 4 electrons over here. These two are undergoing combination. And so there are a total of 6 electrons. Transition taking place from here to the top, and this is CT, means charge transfer. Okay, so we can say over here interaction of the bromine iodine with the carbonyl group of propanone is shown in the figure as we have seen. And this particular illustration shows the transition responsible for the absorption band observed when the complex is formed. Okay, so this is the complex that is formed, that is with the solvent and iodine, and this is the transition that is being taking place. Okay, so here the transition is taking place from where? The orbital in which the transition occurs is predominantly LUMO of the acid, that means the dihalogen over here, which is accepting the acid. Here means the Lewis acid. Okay, and the ketone is basically the Lewis base. So here, this particular type of transition is our charge transfer transition. So if you go back now and look at the options were interaction of the lower lying sigma star orbital of the iodine with the lone pair, which is true. Formation of a charge transfer complex, okay, which is also true. So that is why the answer is going to be B and C only over here. Okay, I hope that explains the query that you had. Thanks for listening. Have a great day.